Hi, Assalamualaikum. Today I will present about my first assignment from EMJ32204 electrical machine uh, about DC motor. Before that, I will introduce myself. My name is Ahmad Nabil bin Muhammad Amin from electrical engineering student. So my title is what is the difference between electromagnetic torque, load torque, and frictional torque. Before that, I will explain what is DC motor. A DC motor is any of a class of rotary electrical motors that converts direct current electrical energy into mechanical energy. The most common type rely on the forces produced by magnetic fields. Nearly all types of DC motors have some internal mechanism, either electromechanical or electronic, to predictably change the direction of current in part of the motor. Basically, in the motor, it have rotor and stator. In stator and rotor, it have winding. The wire around a lot of wire will be the winding. We call winding. Next, what is the electromagnetic torque? This is our topic that I want to explain. Electromagnetic torque is the torque which is required to start the rotation of a motor. Electromagnetic torque is generally equal to load torque. The output of electromagnetic torque produced over armature in the air gap is the load torque during no-load condition. Load torque is equal to the electromagnetic torque. Is that the electromagnetic torque and the load torque is directly proportional. When the electromagnetic torque increase, so the load torque is increased. So next, what is the load torque? Load torque is the torque created over the shaft by the load current. Load torque is directly proportional to the electromagnetic torque. As load torque increases, the speed automatically decreases, the electromagnetic torque also decreases. Finally, what is the frictional torque? Friction torque is the torque caused by the frictional force that occurs when two objects in the contact move together. Like all torques, it is a rotational force which may be measured in Newton meters or pound-feet. And well, it have static friction when the motor is stopped. When the motor starts turning, you have dynamic friction. Since most parameters of the motor are measured that include the friction. All friction coefficients are measured. That is not a good way to say this is A material with X surface roughness rubbing against B material with Y surface roughness and predict a predicable coefficient. It has to be measured. If one really want to find the friction, there is a way to calculate it from the value list in table. It's messy and you would get an answer that is off from the real world value by some degree, but it can be done. It would be better to measure it. So to find the frictional force in the motor, we would have to know the coefficient of friction between each material between the shaft and the motor and the normal force of the shaft on that material. Measuring the friction of the shaft and bearing could be done by using a force or torque gauge and some knowledge of how to compute moment from force. And keep it in mind, the static friction will be different than when the motor is in motion. And finally, we don't calculate it. We don't calculate it. We measure it. It is purely mechanical effect, depending on things like bearing quality, and aerodynamic effect. In general, motor frictional losses are ignored. If we have to take them into account, we working too close to the edge. Thank you.